Hey TechKnowStuds, in this video we're going to get into VLAN Trunking Protocol, or VTP. VTP is a way that we can configure VLANs on a single switch and then have those VLANs propagate to all other switches within a domain. And it's a quick and easy way to administer a whole enterprise network. However, this could actually be a whole module. We could get really in depth into VTP and configuration of VTP. In fact, in the past, that's the way the CCNA is that it was much more focused on, but they've removed most of the questions around VTP. So we're going to learn just the basics around VTP, enough for you to answer those questions on the CCNA. We'll kick this video off by getting more in depth into VLAN Trunking Protocol and what it looks like. We'll talk about different modes when it comes into VTP. We'll talk about the advertisements. We'll get into domains and how we can have different domains. We'll talk about the configuration revision number. We'll get into what will happen if we add new switches to the domain. We'll talk about one of the problems that can exist, which is one of the reasons why VTP is not really recommended to implement on your enterprise network. And then we'll finish things off talking about versions. The first thing that I want to stress is that VLAN Trunking Protocol is not trunking. In fact, I don't really like the name VLAN Trunking Protocol because of this trunking that's within the name. It misleads us a little bit. When it comes to VLAN trunking is when we are passing multiple VLANs across a single connection here. And we're going to get much more in depth into that. We're going to have whole modules that are going to be based off of trunking and what that looks like. From a VLAN trunking protocol, what we're doing is we're transferring VLAN from switch to switch. So essentially with our diagram that we have right here, we have 4 different switches. And if I were to set up, let's say we had in our network, we wanted 10 different VLANs. What I would have to do is I'd have to configure essentially 40 VLANs then. I'd have to go to this switch and configure those 10 VLANs. I'd have to go to this switch and configure these 10 VLANs. I'd have to go to this switch, configure those. And quite honestly, with the way I set up and configure devices, this really wouldn't be a big deal because I just type it all up and then get onto each one of these switches and paste it onto each of these switches. So 4 switches would be nothing for this. But let's say I'm dealing with hundreds of switches. Now suddenly this becomes a big deal where I have to get onto 100 different switches just to program these 10 VLANs, and that can be problematic. So VLAN Trunking Protocol will allow a single device to start communicating with the other devices. So when we configure a VLAN, let's say we configure VLAN 20 onto this device, that it gets propagated and sent to all of these other devices. And now all of these other devices has VLAN 20 on it as well. And it does this through VTP Advertisements. What happens is when we set that VLAN up on this switch, then it sends out a VTP advertisement that gets sent to this switch so it can get set up, and then gets sent to this switch and it sets it up on that switch. Ultimately, this is going to be a simplification of VTP, but this is one of the advertisements that we could possibly see going between 2 switches when it's communicating these VTP information. And some interesting fields that we're going to take a look at here is the version number. There are different versions of VTP, so it needs to know the version. There's a management domain, and we'll get into what the management domain looks like, a configuration revision number, an updater identity, a update timestamp, and an MD5 digest. These VTP advertisements get sent back and forth between these switches so that the information gets propagated to all of these devices. Now, we do have different modes, so we can actually set each one of these switches to one of 3 modes. We could set it to as a server, we could set it as a client, or we could set it to be transparent. So let's take a look at what these different modes look like. No matter which mode that you have set up on a switch, whether it's server, client, or transparent, they're all going to transmit and receive advertisements. So they're all going to receive advertisements and they're all going to transmit those advertisements. But what we have here is if it's labeled as a client, it does one additional step. It takes that that advertisement and actually processes it, which means that a client can change its VLAN database to update it. But a transparent one will only transmit and receive these advertisements without updating its VLAN database. A server is the one you can actually do the modification on. So this is, if I want to make a change across my network, I would have to get onto a server to make that change. So on this network right here, this main core switch would probably be the server. And then these other switches on here would probably be clients. However, for the purpose of this, let's just say that we want to make this one right here transparent. Maybe there's something special about this one right here where we need to do a little different configuration on it. So we're going to make this transparent on here. And so what will happen is we will make the change on the server. The server will then send an advertisement out to these devices right here. This client will make the change. Let's say we're adding VLAN 30 to this. Now this client will add VLAN 30. It'll get sent out to this transparent one. That transparent one will forward it on to this client, and then this client will add 30. But 30 will not get installed on this switch right here because it's set to transparent. One of the key things to this is that these switches need to be on the same VTP domain. So what I'm going to do is I'm going to configure or go on to these different switches, and maybe I configure these two switches as admin. At that point in time, this switch right here would then send advertisements out, but this other switch, since it's on the same domain, will actually be listening and will update its own VLAN database. Although if these two switches now, let's say they're on a different domain, so maybe they're on the sales domain. If these two are on a separate domain, then these would act separately and they wouldn't get the update. If I'm updating it, let's say VLAN 40 on these devices, these two would not automatically update because they're part of a different domain. Another key factor is the configuration revision numbers. The configuration revision numbers increment up as we make changes, and it tells all of the other devices what version the database is on. And so what we have right here is, let's say all of these switches are on the same domain. So maybe we just have one single domain called admin for it's the same VTP domain. And so it's all admin. And let's say this is the server right here. These are all clients right here. And we're on revision number 101. It starts at 0 and counts its way up. But let's say we're on revision 101 and we add revision, let's say we add VLAN 50 to this. Now it goes to 102. It's going to send out advertisements. And within that advertisement, it will say who this is from, so this server right here, and it will also have a revision number of 102, and these devices will now see that they're on revision number 101 and realize that they need to be updated now, and so they'll need to get updated. Now we start seeing where the components of the advertisement is important here. We've got the management domain. So this management domain says, should I be listening to this advertisement or not? We also have the configuration revision number, so it can compare against the revision number it has to know whether it needs to be updated or not. It has the updater identity, who made the update, because you can actually have multiple servers within your network. And then we have I'll just point out the MD5 digest here is just a check to see if anything has changed or if there's any corrupt data within this advertisement. Let's see what happens if we add a new switch here. If we're adding a new switch, and let's say it's a fresh install, and so the VTP domain is null. That means there's nothing in it. It's not been programmed for anything. We add that to this switch right here, and this switch is set up as a client, and so it's now sending some VTP advertisements out. And let's say, once again, it's for the admin domain here. So it sends that out. This switch sees that there is a VTP advertisement and it receives this VTP advertisement. And what it will do is it will actually do an update of its domain. So it'll add admin as the domain here and become a part of this VTP domain. So you don't need to do anything on the switch, you just add it and then it will automatically update. Now this introduces a couple problems because maybe we don't want this switch necessarily to update with it, or there's even a more significant problem. Let's say this has been a switch that we took out of circulation, so it already was part of the admin VTP domain. We took it out and we were doing some testing on it and we were adding some VLANs and we were testing it out, and now the revision number is at 150 where everything else is at 102. Now this causes a problem because now when we reconnect it to the network, it will see that this has a revision number that's much higher, and then we'll start updating, if it's a server, start updating all the rest of the database. And so it can cause a lot of problems on your network. So you need to make sure that this switch right here is completely wiped before you put it on the network. And so this is one of the reasons why you probably don't want to be using VTP on your domain, and there are better solutions to be able to manage your whole domain and the VLANs on your domain. And there are different versions of VTP. And I don't have them all listed out here, but here's a few of the version differences between 1, 2, and 3. First of all, the VLANs that are supported, the version 1 and 2 is just 1 through 1005, versus the version 3 has the extended VLANs supported as well. We see that version 1 doesn't support token ring. We see that version 1 doesn't have error checking, and version 1 and 2 have clear text with their passwords. So there's an authentication piece that can happen, and the passwords are sent in clear text, which is not something that we want. So version 3 has it as being encrypted. So there's VLAN Trunking Protocol. We covered what VLAN Trunking Protocol is, the different modes. We got into the VTP advertisements and what those look like. We talked about domain names, and they need to have all the same domain name if you're going to use VTP within a domain, or you could separate it out into multiple domains. We talked about the configuration revision number and how that increments up so that we can track the changes and make sure that the devices are all updated. We got into what happens if you add a new switch and one of the problems with adding new switches. And then we got into some of the versions of VTP. Now, it's unfortunate that, to a certain degree, I guess, that we can't go more in depth into it because I really do like teaching VTP. It really is a cool protocol, but ultimately it's not something that's I've used in production out there, even with my larger enterprise networks. And so it's not something that's really recommended. And we've gone over the basics of what you really need for the CCNA.